Students, today we are going to learn about the estimation of copper in brass. So we are going to take the required chemicals. The first thing that we are going to take is the brass. We need a sodium thiosulfate solution, standard sodium thiosulfate. We are going to take 10% of Ki, acetic acid, sodium carbonate and concentrated HNO3. The apparatus required for copper in brass are conical flask, volumetric flask, burette, measuring cylinder and distilled water. For the estimation of copper in brass, we need to take the pieces of brass, we need to dissolve it in concentrated HNO3. A minimum quantity of HNO3 we are supposed to take. So now I am going to add this HNO3 for the dissolution of brass. Once HNO3 is added, the oxides of nitrogen are going to liberate and see here, you can see this, the brown gases are coming and brass is dissolving. Now we dissolved copper in brass. So already the oxides of nitrogen is expelled. Still, if any traces is present, that we are going to expel by addition of a small quantity of urea. So by doing that, we are going to get a blue color solution. So to that solution, we are going to add 10 to 15 ml of water. See this, the clear blue color solution, we are getting it. Now I am going to add a minimum quantity of Na2CO3 so as to remove the excess of HNO3 that is present in a solution. So with a constant stirring, we need to add this Na2CO3. See that you can see the blue PPT here. After adding, we are getting the blue PPT. With a constant stirring, we need to add this Na2CO3. You can see the blue PPT. Make sure that whatever the excess of Na2CO3 is there, that expelled out. Now I have added Na2CO3. All the copper that is precipitated out as a blue PPT. To this, now I am going to add acetic acid. So I am taking this acetic acid bottle. So now I am adding the acetic acid dropwise till the solution becomes clear. A shiny blue color solution, we are going to get it. So that we are going to see. So now add dropwise with a constant stirring. That PPT is again redissolved into the acetic acid. This experiment is carried out in a neutral medium. That's why we need to add a calculated amount of, very minimum amount of acid as well as base to this solution. See now, this is a shiny blue color solution, we are getting it. Now I am going to transfer this solution into a volumetric flask. I made this solution to 250 ml. So here is my volumetric flask. So I am going to take this one, which is already washed and rinsed with the distilled water. So this is the funnel which I am going to insert it, which is also rinsed and kept it. So now I will take this solution back into the rack. So now I am going to transfer this solution into the volumetric flask. With the help of a glass rod, I am going to transfer this. Wash the beaker about 2 to 3 times. Collect the washings into the volumetric flask. Yes, now we prepared the brass solution. Now I am going to take some of this solution into a beaker. From here I am going to pipette out 25 ml of this solution into clean conical flask. So this is my conical flask. In that I am going to pipette out. So pipetting out this 25 ml of solution into a clean conical flask. I am going to add 10 ml of KI solution to the bottle. Once we add a KI, there will be liberation of iodine is going to take place, so which we need to titrate immediately. That's why this particular titration is called as a rapid titration. So before adding, we need to make sure that the pipette burette is filled with sodium thiosulfate. So already the pipette is filled and it is ready to titrate. Now I am going to add 10 ml of KI into the solution. Once I add this one, this is going to, iodine is going to liberate. So the liberated iodine I am titrating against sodium thiosulfate. So now the reading is 0. Let's see. Till it becomes a pale yellow, we need to titrate it. Once it becomes a pale yellow, we need to add the starch solution. Starch is going to act as an indicator. Now the solution is pale yellow. I am going to add the starch solution. Add 2 more drops of this sodium thiosulfate. Then I will add the starch. 1 ml of starch I am going to add. Once I add a starch, the color of the solution turns blue. So this is the blue color. So dark blue color I am getting it. So now I will titrate it with a dropwise addition with a constant stirring. Once the color is colorless, we need to stop the titration, note down the reading. So now the color of the solution is turned colorless. Still a tinge is there. So I'll add 1 or 2 drops. Just I'll check it. Right now I'm getting a reading of 8.5. No further change is observing, so I am taking this as a end point. So now the reading is 8.6. So this is how we are going to do the estimation of copper in brass. In the same way, one more reading we are going to take. So I am pipetting 25 ml of this KI solution, 25 ml of this USO4 solution I am taking in a conical flask. I am going to add 10 ml of KI. Once I add, the liberation of iodine has started. So right now my reading is at 8.5. I'm going to do the rapid titration. Till it becomes a pale yellow, we need to titrate it. So right now I'm finding it is a little bit pale yellow. So now I'm going to add 1 ml of starch, which is going to act as an indicator. So this is a pale yellow. So now I'll add one more drop. I'll add it. So now I'll add 1 ml of starch. So the solution turns blue. Now I'm going to do the titration dropwise. Slowly I'm going to do with a constant stirring. Rigorous stirring should be there. So now the color of the solution is colorless. I'll add 1 or 2 drops and check it. So now the color of the solution is changed. So I'm noting down the reading. So previously I got it as 8.5. Now also I got it as 8.5. So in this way we are going to take the readings for this estimation of copper in brass. Weight of the brass taken is 210 mg. In the burette we have taken the sodium thiosulfate solution. In a colloidal flask we have taken 25 ml of brass solution. To that we have added Na2CO3. Then we have added the acetic acid. Then we have added 10 ml of Ki solution. So after adding a Ki solution, the iodine is liberated, and then we have titrated. The readings what we got is, first reading we got it as 8.5, second also we got it as 8.5, third we got it as 8.6. The average of these three things we are taking it as 8.5. So the volume of Na2S2O3 sodium thiosulfate used for this titration is 8.5. The normality is 0.025 N. So therefore we know that 1000 ml of Na2S2O3 is going to correspond for 63.54 copper. So therefore 63.54 grams of copper. Therefore 1 ml of 1 Na2S2O3 is nothing but it's going to count for 63.54 mg of copper. Therefore we are going to calculate the copper in terms of Na2S2O3. So for that we are going to take 63.54 into 8.5 into 0.025, which is going to come as 13.5 mg, which is present in 25 ml. So we'll calculate for the 250 ml of brass solution. So that's why we are going to multiply whatever the answer we have got here. So that's why I'm going to multiply the Y with 10. So at that time I got it as 135 mg. So the percentage of a brass in a solution can be calculated by multiplying the by multiplying this Z, that is 135 into 100 divided by the weight of a brass. So to do, after doing that one, I'm going to get it as 64%. So the result is that the percentage of a copper present in a given brass solution, brass foil is 64%.